Oh my god. Yes.
All right, so this is kind of a new thing, but also kind of not really a new thing. Here's the idea.
I have a nurse man to pick up my hair. She's a vet.
Yeah.
You're fine. She cleans dog cages.
Take Advil, go home.
That's right.
Take nap.
Take Advil and go home. I like that advice.
Go to
Is Tylenol the
Oregon,
same
play the
as
game.
Advil?
Come home,
Come
shower,
home.
go to sleep.
Yeah,
do it
shower,
all over
take
again.
nap.
No, this is our last game.
I showered last night.
For me.
Sleep.
This is your last game tonight?
Take
Yeah.
another shower and take nap.
Sorry.
Drive to Oregon, come support.
Of
15
course.
minutes away.
Oregon, the state, not
Of course.
not
No.
the town, the state.
I almost moved to Oregon once.
That's
Both the town and the state.
You know what? By Mount Colorado, and every once in a while, I think they're
I used to live in California.
For real?
There's a game
Yeah.
day and I
Wow.
want to go to it.
My sister was born there.
That's amazing. Is your sister older or younger?
She's in 8th grade.
So,
I have a lot of siblings, so.
Eric Mack,
are you
we're
the oldest so
live!
much?
Yeah,
Guys,
there's 8th
Oh, we're
grade.
live.
I get
There's 8th
notifications.
grade, 4th
And
grade,
your
3rd grade.
Turn on your
second.
post notifications.
I'm not
Two-year-old,
you
and then there's a
kidding?
panel month old.
I've never been on
I
it.
have my post notifications.
Alright, so let's talk about triangles.
Watch live now, Derek Mack.
I really don't want to. But
Similar
do I need a
triangles
paper?
to
Oops.
Do I need a paper?
Shelby, I'm
No.
not snapping you anymore if you don't send me
Sincerely.
a picture.
Oh,
You made it go.
I know, I made it gross. Which one's this?
What the
live
heck we
stream,
gonna
right?
do now? Oh, that's me.
Sorry,
I
my
did
bad.
TikTok.
Show me how to do it.
The one that has 71 subscribers, almost 100.
That's right. Okay, let's talk about these triangles.
We don't talk about it.
We have two triangles, A, B, C, and D, E, F.
These times I start coughing, I'm gonna.
And these numbers have to do with their side lengths. So, are these triangles congruent? No way, Jose, they're not congruent. Look at them, they're different lengths and stuff, which means they can't be, right? Because congruent means all of the angles and all of the sides match up. However, if you notice, there is a connection between these two triangles. What is it?
3 sides.
Yes, they all have 3 sides
They
and
all
3
have
angles.
3 All their angles add up to 180.
This is also true.
They both are not isosceles.
Ooh, wow. I like this. This is fun. Keep going.
No.
Give me everything except the answer I want.
They all have different numbers.
They all have different numbers.
And different
very good.
letters.
And different letters. What else?
One's bigger than the other.
One's bigger than the other, yep. And
One's
one's
smaller
smaller than the
than
other.
the
Yeah! Yeah. What else we
One's
got?
EDF,
One's on-
one's BAC.
Yeah, we already said that,
Oh, I
Jericho.
was hot.
One's on the left side of the page and one's on the right
This
side
is
of the
correct.
I just said
Give me
that.
more.
One of them adds up to 12 and one of them adds up to 24.
Nice. Ooh, that's interesting. So one adds up to 12, right?
Shelby.
Wow.
Shelby.
And then 6 plus 8 plus 10
That
is
was like
24. So that's interesting. Okay, what else we got?
Is it really a right answer?
That's not
One
wrong.
is higher than the other.
One's higher than the other. This is true.
I
One's
like
bigger
wrong.
than
I
the
like
other.
wrong answers only. Those are fun.
Yep.
They're
I like
I'm
wrong
gonna
answers
do
only
one
too.
of those someday.
One
This
is
is all.
Have we never done wrong answers only in here?
No.
Oh, we'll have to do this sometimes for a while.
How about today?
No, I mean we kind of are. All right, keep going. I mean they're not wrong answers; they're just not the right answer. The thing
You'd
I'm
be like,
looking
what
for.
state are you in?
What else?
Diarrhea.
What else do you
What
notice?
state are you in?
Oh, come on!
No, that's not. That's
What else do you notice?
That's not readings. Sorry, this is my mistake.
Are we saying how they're different? or the
No.
same? They're both pink.
What do you notice about it?
That is not pink.
How's that pink?
Purple.
Burgundy.
Are you colorful?
brown.
Chartreuse.
It's brown.
It
Brown.
looks like magenta purple.
That's brown.
It's literally like dark purple.
What kind of?
It's brown.
That is
Wow.
the farthest from.
I think we learned something today. Taylor does not know her colors.
Shelby, it's actually brown.
Oh wait. Is it actually?
Yeah.
3
Wait,
is
is it
half of
brown?
6,
Yeah.
and that's one of the
No.
sides.
Ooh! So 3 is half of
Yeah, I
6.
held it up.
I'm
Whoa.
literally
What else?
so good at
Whoa.
this, except for when
5 is not half of 8.
Nope, it's
It's
not.
twice the size.
But 5
But
is
it's
half
not.
of 10.
Oh, 5 is half of 10.
4 is half
And
of
4 is
10.
half. Oh my god! Right, they're double. Look, when you add them up, you can see, right? So, the relationship is double or half depending on which way you're going, right? If we're going from 3 to 6, we double it, right? But if we're going from 6 to 3, we have it. So depending on which side of the equation you're looking at, that's what's going on. Excellent job. So, these triangles are said to be similar because they have a proportion that relates them. Okay, whoa, 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 whoa. What about porpoises? I know. here's the deal. So if you check it out, you'll notice that AB, the length of AB. Now notice I'm not using a bar over the top, so I'm not referring to the figure, right? The figure is this line segment. AB without a bar over the top is talking about the measure of AB. Does that make sense? Right? So when I say AB without a bar over the top, what I'm really meaning is 3. Everybody cool with that? If I divide that by DE, well, what this is, it's 3 over 6, which is a 1 over 2 fraction. So notice that AB and DE, when I divide them, is 1 over 2. And if I take AC, again, starting with the small triangle first, right? AB is from the small triangle, AC is from the small triangle. Then I go to the big triangle, it matches up with EF, because when I do that, I've got 4 over 8, which we know simplifies to 1 over 2, or half, right? And then lastly, I've got BC from the first triangle, that's 5, and it matches up with DF over here. And how do I know it matches up? Well, because if I write 5 over 10, I also get a half. So notice that all of these are the same. So another way to write this would be to say that AB over DE equals AC over DF equals BC over DF. So AB is not the same as AC, right? We know this. AB is 3, AC is 4. We're not saying they're equal. We're not saying DE and EF are the same because DE is 6 and what is the last one? EF is 8, right? But when we put them in ratio, right, divide them by one another, then they do end up being the same. When this happens, we say that the triangles are similar. So the idea is that they're related by some number. In this case, because I started with small and went to big, the number is a half, right? So from 6 to 3 is half, 8 to 4 is half, and 10 to 5 is half. Now notice, just because they're not lined up correctly doesn't mean that they're not necessarily in ratio, right? Sometimes you got to get a little creative. I think some of you guys were thrown off. 3 and 6 go together, but 5 and 8 don't. Well, look a little bit deeper, right? Don't be thrown off by that. So depending on how you organize these, either small on top and big on bottom, or big on top and small on bottom, you'll get a half or 2 over 1, right? And as long as you're consistent about which triangle you start with, you'll get the same ratio for each. When we have ratios or fractions being compared to one another by equal signs, we call this a proportion. So when you have 2 fractions that equal each other, we call that proportion, right? We know that 3/4 is proportional to 6/8, right? They're the same thing, just different way of writing it. One's simpler than the other because 3/4 is easier to work with usually than 6/8. But they're all the same. So when the sides of the triangles are proportional, meaning that we've got 3 matching up with 6, 4 matching up with 8, 5 matching up with 10 in the same way, by half, right? When this is true, this means that the triangles are similar. And so what we would write is that triangle ABC is similar to triangle DF. And again, just like last time when we were matching up letters, very carefully, we need to be careful to match up the letters here. You'll notice that A is made up of 3 and 4. And over here, that's going to be a 6 and 8, right? So what's 6 and 8? Oh, it's E. Ah, man, I wrote the thing wrong. That's annoying. So E goes with A. If I look at B, B is 3 and 5. That's going to be 6 and 10 over here. That's D, so D goes here. And then C is made up of 4 and 5. That's going to go with 8 and 10. 8 and 10 is F, so that's the correct order for these letters. Now, the reason we order these letters carefully is, 1, it's more correct, and 2, we're going to be able to do something kind of like CCP with similar triangles. So, for instance, we know CCP means corresponding congruent parts. Well, these aren't congruent. We've already established that, right? They're not the same triangle, but they are similar. So we're going to call it, instead of CCP, we're going to call it corresponding similar parts, CSP. Cool. So which parts are similar on the triangles? Well, I could look. 3 goes with 6, 5 goes with 10, 4 goes with 8. But just by seeing this, if I just gave you this, just down here, you can tell which parts are proportional, which parts are similar. Corresponding similar parts. So notice that AB and ED are in the first and second spot, right? That means AB and ED are going to be similar. I'm going to write it DE, just so I keep it alphabetical. Doesn't matter, right? So AB and DE are going to relate the same way that BC and DF do. And that's going to relate the same way as AC, first and third, and EF do. If you notice, just from that information right there, I have the exact same thing here and here. A, B, and D, E, B, C, and D, F, A, C, and E, F. Cool. So, similar triangles have similar proportions. It's not always going to be easy as, oh, double it, right? Or have it. But they're there. And if the triangles don't have that, right, then they're not similar. So here's an example of a triangle that would not be similar. I think this is obvious, right? 1 times 2 gets us 2. 2 times 2 gets us 4, but 2 times 3 does not get us 9, right? And no matter how we try to arrange this, there's no way that makes it work. You could say, oh, well, 1 times 4 gets us 4, but none of these times 4 gets us those, so that's not going to work. 1 times 9 gets us 9, but none of these times 9 gets us those. So these triangles are not similar. They're just not going to be. Their sides are not proportional. So if you were to compare their sides, they would have different ratios. 1 to 2 is a half, 2 to 4 is a half, but 3 to 9 is a third, right? So they're not going to be similar. Another way to look at similar triangles is through their angles. So it turns out, even without measuring their sides, if you were to take two triangles, and we know that these angles match, and these angles match, what do we know about the third angle?
They match.
How? How do you know?
Because they have to equal the same in the middle.
Right. So they're going to add up to 180, right? So this angle is going to be equal to 180 minus the 2 band minus the 1 band, right? And this angle is also equal to 2 band minus 1 band. So they must be congruent by angle addition postulate, right? Something like that. So these angles are okay. So I don't even need to know the third angle, because if I know 2, I get the third one for free, right? So if I know 2 of the angles, that's enough to say that these triangles are actually similar. These angles are going to lock in what the sides have to be, and those sides aren't going to be the same necessarily. They could be, right? But they're going to be in proportion no matter what they are. So just by knowing 2 angles, we can say that these triangles are similar. So we have AA similarity, and that's a postulate that we're going to be using. So to say the triangles are similar, we can say, oh look, they have 2 angles the same, so they must be. That's all you need. Because if you have 2 angles, you get the third one for free, right? We could call this AAA similarity if you wanted, but really 2 angles is enough to get it done, because the third one you get for free, right? You noticed earlier that we talked about the sides. So knowing that the sides are proportional, right? If we know the angles are the same, that's enough to do angle similarity, and we're good. Now we know the triangles are similar, right? If we know the sides are proportional, meaning that they have the same ratio, right? 3 compares to 6, the same way 4 compares to 8, the same way 5 compares to 10, half, right? Then we know that the triangles are proportional as well. So we call this side, side, side similarity. So if we know all 3 sides are proportional, right? If this is true, we know that the triangles are similar. Here, if the angles were exactly the same, then we know that the triangles are similar. And we only need 2 of them. Here, if we have 3 sides. So you'll see that some of these kind of have overlap with our congruency ones, right? Side, side, side congruency. We've used that before to prove that 2 triangles are congruent when all the sides are equal, right? Here we're saying if all the sides are proportional, then they're similar, right? So let's talk about the other ones that we have. We know from congruency that we've got side, side, side. And from similarity, that's the symbol for similar. It's just the tilde, the top part of this, right? We know that side, side, side also makes an appearance. We call it side, side, side similarity. We know from over here, we've got angle, angle similarity, right? We've talked about that just a second ago. We don't have any angle, angle over here, right? 2 angles is not enough to prove 2 triangles congruent, right? That's not one of our things. What are the other ones that we have for congruency? Side, angle, side. So let's write that. Angle, side, angle. Any others?
SSS.
Already got it?
Oh.
Yep, that's okay.
SAA.
SAA, I'm going to write AAS, but yeah, same thing, right? I don't know why I write, like, I like writing A first. No, we have HL, right? Cool. So, AAS, is that going to show up over here for similarity? What do you think? Yes or no? There's a way to figure it out. How do you know? Will AAS also be something that works for similarity?
Yes.
Why?
Because it has AA.
Exactly, right? So we don't need to move this one over and say, oh, AAS works, right? Because if you already have two angles, you've already got this, right? Kind of like how we don't need to write AAA over here because we already have AA, right? You get the third angle for free. We don't need AAS because we already got AA over here. So this one kind of is the same thing as this, right? So if you've got that, you've got this. So AA similarity. SAS. So we have two sides and an angle set between them. So we have something like this. Here's two sides of a triangle. Let's do, actually let's do this. Here's two sides of a triangle. 4 this way, 2 that way, right? And I've set a particular angle. So that's side angle side. And here's another triangle that I set up, which is 2 and 1, with the same angle here and here. Now, I think you can tell, without me having to draw another line on here or a line on there, how long that segment would be, right? Right? You can tell how long it would be. You might not be able to say, oh, it's 2, oh, it's 1, oh, it's 3, it's 2.5, whatever, but you know how long it's going to be. It's kind of locked in. You guys see that? Right? There's only one way to make this into a triangle, and that's what I'm locked into. Same thing here. So, is this side proportional to this side? 4 versus 2?
Yes.
It is in some way. All numbers are proportional, right? 4 and 2, how do they relate? 4 over 2 is what?
2.
2, right? What's 2 over 1? Also 2. So 4 and 2 relate in the same way that 2 and 1 relate. So what we say is that these sides are proportional, right? In the same way. 4 to 2, 2 to 1, they're the same. If these angles are the same, right, we automatically know what these sides over here will be. So what we have essentially by SAS is we get that third side for free, and we know that that's something that gives a similarity, right? So if 2 of the sides are the same and the angle set, it kind of locks in that third side, which is why SAS similarity is a thing. So if we have 2 proportional sides, not the same sides, it's not congruency, right? If we have 2 proportional sides and then the same angle, then we say that the triangles are similar. So SAS works, right? That transfers over. What about ASA? Does that one transfer over?
Yes.
Similarity? Why?
Because it has the 2 angles.
Because it has 2 angles, right? Okay, cool. So far we have a lot less things to memorize for this one, right? Because this one covers a lot. HL. I've already got SSS. What about HL? Is that going to transfer over or not?
Yeah.
Why?
Well, it's 2 sides.
It is, but don't we need 3 sides?
No, because SAS has 2 sides.
Yep, but it also has another angle, right? Why would HL work?
Why would it?
Yeah. Or why wouldn't it?
Doesn't it need to be right angle?
What?
Doesn't it have to be right angle?
So this has to be a right angle. So if you're using HL, don't you already know one of the angles? Right? So we know 2 sides, the hypotenuse and the leg, and we must know another angle is 90, right? So if we're using HL between 2 triangles, right? Let's pretend this is a right triangle and this is a right triangle. Now, without drawing those third sides, you know how long they're going to be, right? They're kind of locked in by that 90-degree angle, right? So we have matching hypotenuse, which is locked in, right? And a matching leg, right? Or not matching, I should say proportional legs, 1 to 2, right? So HL is going to work because we have 2 of the legs, right? We have a hypotenuse and a leg that are matching up, right? Or at least proportional. And then we have a matching angle. So we have basically SAS, kind of, right? Yes or no?
Yeah.
Try it this way. That's a right angle triangle. That's a right angle triangle. I just didn't draw in the this side here. So we've got a hypotenuse and a leg, hypotenuse and a leg. We know that this has to be 90, so it's going to go up through there, right? Is there a way for these not to be proportional? No, not really, right? So HL kind of transfers over to SAS. The only reason it really doesn't is because notice how the angle's in between the two sides, right? And the angle we're talking about is over here, ASS. But it's fairly similar. It kind of works like this, kind of. So in general, these are our big 3 triangle similarity postulates, and that's what we're going to be using today. Here's what I want you to do. Hang on 1 second while I print this out. I had to wait for Vanderbilt to get out of the copy room, and I'll grab that for you.
Oh, yes, there is.
I put it as
All right. We're going to start with this, and I think this might help you guys grasp the concept a little better, start seeing things. All right. So we know one way to tell that triangles are similar is just to check if their sides are all proportional, right? Cool. So what if I gave you this? We've got 2 triangles here. We've got the big triangle ABC, and we've got the smaller triangle AD. Right? We've got 2 congruent angles here. My question is, are the 2 triangles similar? So is triangle ABC similar to the other triangle? Now I'm not going to write the letters because we're going to need to check that after we prove similarity, if they are. Similar or no? This triangle or that triangle?
Which one?
Small triangle to big triangle. We have 2 triangles in this. Why are they, Calvin? Do you know why?
2 sides and an angle.
2 sides and an angle? So we need to know that the sides are proportional. We don't know where that hits. I'm not sure where I see the matching sides. We've definitely got the angle here, right? I don't see the matching sides. If I knew that was like 3 and that was 6, I could do that. But what if that was like 2 and that was 5 and this was, you know what I mean? Yeah. They do. So a lot of you bozos were writing shared angle on the first quiz we took, and I'm like, there's no such thing as shared angle. It's vertical angles, right? But now we have shared angle. So I guess you guys went in the end. See how this triangle uses the exact same angle as this? It's kind of like shared side, right? They overlap on that angle. So we know they're going to share that angle. So by shared angle, we know that angle A is congruent to angle A. And I can call it angle A because it's the only angle A, right? For instance, angle E is this angle and that angle, right? So we know that we have matching angles, yes? Ooh, close but not quite. We don't know that these 2 are the same. If we knew they were the same angle, we'd be good to go. Maybe I should use a double band here. I used a different color to indicate they weren't the same. Should probably get in the habit of using 2 bands. All right, so those angles aren't the same. So we can't use isosceles triangle theorem. What were you going to say?
They share side, like the CA.
Right, so this triangle here is made up of side DA, right? It's not shared with CA because it's not the exact same side. It takes up a little bit of it, right? But it's not shared. Remember, a shared side is something like this, where both triangles use the exact same side. Does that make sense? Right? These 2 triangles both share this middle part. This angle, the exact same angle is used by both, and that's why it's shared. You see the difference? So this is not a shared side because it only takes up a little bit of CA. But now we've got 2 angles, which we said earlier is enough to prove similarity. Why is 2 angles enough to prove 2 triangles similar?
Because then the third one's the same.
Because the third one we get for free, right? If these 2 match and these 2 match, right? What is this angle going to equal? It's going to be 180 minus red minus green, right? And what's this angle going to be? It's going to be 180 minus red minus green. So both angles are congruent. So we don't need a triple angle similarity thing because if we have 2, we get the third one for free every time, right? So these 2 triangles are similar. So triangle ABC, and we'll wait to match stuff up in a second, is congruent to triangle this, by angle, angle, and again, that's not a congruency property, so we have to write similarity. Angle, angle, similarity. We have two matching angles, and so that's enough to say the triangles are similar. So let's match them up. A, right, is this green angle here. It matches up with A, guaranteed, because they're the same angle. So A goes with A. This red angle here is angle B. It matches up with E, guaranteed, so B goes with E. And that means D is going to go with C. So A, and they're similar. Now, what does this allow us to say? Well, pretend I knew that this was 3. And that this was, I don't know, how about 7? So AD is 3 and DE is 7. My question is, how big is CB? Could we figure it out? Well, we know that AD, right? AD is first and third. So that should compare to AC the same way that AD compares to everything else, right? So I'm just going to start writing this stuff out. I'm going to say AB, first and second, compares to AD. The same way that BC compares to ED. The same way that AC compares to AD. And I can fill in what this stuff is. AD is 3. AC they didn't give me, I don't know. DE is 7. So that's this guy. BC, I don't know. I don't know either of AB or AD, right? So I've got this. Something over 7 is congruent to something over 3. So we really don't have enough information, but if we knew one of these guys, we could multiply by 3 and figure out what this is. Or multiply by 7 and figure out what BC is. So we need to either know BC or AC. So we want to find BC. That's what I said we wanted to figure out, right? So we need to know AC. What do you want to make AC? Do you see how if AC is like 12, it's going to push this farther away, which is going to make that bigger, right? If AC is really short, like 4, it's going to move that in closer and make this guy smaller, right? So we need to know what AC is. What number do you want to make AC? 6. Okay. So if AC is 6, we get this. What's 6 divided by 3? 2. Whatever BC is, when you divide it by 7, you should get 2. So what's BC have to be? 14. So you see how 3 relates to 6, the same way 7 relates to 14. 3 and 6, 7 and 14. Right, I'll be back in just a second.
What did you have speech last semester?
Oh, speech.
So now how'd you tell us not to
For you.
demonstration videos for IT?
For you. For you.
I didn't do that. I don't.
For you.
You should have.
For you. For you.
Jake.
For you.
And also, I wasn't facing
For you, Bo.
Thank you.
For you. For you.
So she's gonna be extra.
For you. For you.
I'm doing
For you.
What'd you
For you.
nothing. Like, oh, but I do that. I made chocolate chip cookie cheesecake. My grandma was videotaping it, and she didn't do it right.
Grandma.
Now I'm gonna be, Miss Robinson is gonna be so.
Grandma Miller. Is that what we're talking about?
Grandma Bush.
Grandma Blush.
Bush.
Bush? Oh, how does she spell it?
B-U-S-A.
Oh, gotcha. My grandparents are Boucher, which is French. What is it? Like Bobby Boucher.
I heard Scottish.
I'm also Scottish, yes. So my dad's like very, very Scottish. And then my mom is like part French, part English, part a bunch of stuff, right?
Mark is Russian.
And also,
I know.
I hate the way I sound.
But my dad is very, very Dutch. I don't know how much, but very.
Calvin, listen to what I'm about to show you. Just put it by your ear.
Okay, so it says A, B, and D, E are line segments. And not only that, but they are parallel. So A, B, parallel D. And we want to prove that A, B, C, and D, E, C are similar. So remember, to prove something similar, we need double angle, right? For similarity. We've got triple side for similarity. And then we've also got, where's our last one? Where's our piece of paper go? SAS, right? Now, spoilers, did they give us any information about the sides at all? No, right? So good luck getting any information, right? So it's going to be AA that we're going to end up using. So we need two matching angles. What do you think? Go ahead.
Extend the lines.
Yes, extend your parallels, always. So let's do that. H for Housingay. I can't do B for Bailey. I already did H. I can't do H. J for Jerica. S for Shelby. P for Pot. All right. So let H, D, E, J. And let P, A, B, S. Pads. Pads, glue, ribbon. Heineken. All right. Sorry. Just quote from yours. David Lynch.
I'm exhausted.
Did you say I'm exhausted?
Yes.
Guys, this is the easier stuff. It's going to be fine. All right. What do you see? What do you see? Hannah! Can we use what? Yes. Whenever we have parallel lines, you should be thinking cat. And eventually we're going to cut to the chase and do like alternate interior angles and all that crap. Okay? Yeah. Yeah. Check it out. We have two parallel lines cut by a transversal. So top left or top right corner, top right corner. So I'm going to call that angle, since I got lots of angle D's, right? I'm going to call that angle CDE congruent to angle DAB. Don't you dare. Jerica.
What?
You and Katie.
It's Zayden. It's usually Zayden.
Totally not Zayden. All right, so those two angles are the same. What else do you see? Hannah! Yeah, these two angles are congruent. Now, we do not know that they're congruent to the pink angles, right? Because we don't know what angle that transversal's going at. He's doing his own thing. But we know that the angle here and the angle there will be the same because we have two parallels cut by a transversal. Oh my God!
No,
Bailey, are you okay?
Let somebody else shine.
Can't breathe.
Hannah is letting everyone shine. She's shining the brightest. All right. This is by cap. This is by cap. Hello.
Which one do I take for?
I don't care. Just take some. It's not organized anymore. It's what happens every day. All right. And now what, Shelby?
I don't know if this is relevant, but there's vertical angles.
Ooh, there is. So we can find out a lot more about these angles. However, do you see two triangles that share two angles?
Yeah, I made one.
Then by angle similarity, we would. Yes, but we could get vertical, right? We could match up these guys, go in a pair, right? And that's all fun. Maybe that's useful for a later diagram. But right now, we're taking it easy, Shelby, because we're exhausted.
Yeah.
Okay?
You're right.
So, by angle, which is not a congruency thing. These two, I swear to God, these two triangles are not congruent.
Why?
I mean, they could be, because like maybe like I just drew it really poorly, and that line's actually the same line as that line,
Maybe.
and it's like this. Maybe. I don't know. Maybe. I don't know. But we do know they're similar at the very least. By angle similarity, which we will abbreviate as sim.
Why did you write
I
that?
figured you would like the sims.
I only
I
like
used to play The
Sims because
Sims.
Hannah played The Sims.
I only like this.
Hannah played The Sims.
Hannah
Okay, I
played
literally
all the
had such a
time.
good.
No one asked, no one
sound
cares.
going, and
This
then
is
my
like
sister-
kindergarten. When I
my
say
sister
one thing,
ratted
everybody
me
raised their
out,
hand,
and
wants to
then
tell
I
me a
had to get
story,
rid of it all.
and no one asked.
Literally.
No one
You're
cares.
right, so true. Can we just
By
do-
angle, angle, similarity.
We have to write similarity.
Triangle AB. No, you can write sim.
Sim.
This is the whole purpose of me saying the sim thing, and all you got out of that was I like the sim.
I do like The Sims. As a matter of fact.
I'm like, great. They're gonna remember that because I made a memory in their head instead of it just being this abstract thing, right? Memory in their head because we talked about the Sims. But in reality, all you're gonna remember is I like the Sims. I wish I was home. All right. So A, B, C. A is this pink angle, so it's gonna match up with D, for sure. For sure. And B and E match up, which means that C matches with itself, which makes sense because guess what, guys? C is the shared angle. You guys didn't even see it, so there's another way to do this, right? Don't both triangles share that angle?
Yeah.
So we could have stopped after that, right? We could have stopped after that. By shared angle, right? And then by cat. Wow! Wow!
Did we solve it?
Have you not seen that? The lobster? I would like to touch it.
Swag on.
I would not like to touch it. No? Okay, we'll have to watch the lobster blade.
Can we do that right now?
Nope.
We should.
How do you feel about that?
Pretty good.
That means that the parts
You.
are similar.
Similar.
So instead of CCP, which is corresponding congruent parts, it's corresponding similar parts, CSP. Okay? So if we wanted to, we could say that I know that by CSP, AB and DE must be proportional. So AB and DE are proportional in the same way as the rest of the triangle. So if AB was 7, right? And I knew that this whole thing was 12, and this little bit was 6, right? If that was 7, then this would be 7.5. They all relate the same way. Number 2. DB and AE are line segments. Do not be fooled. That's all it says. BD and AE are line segments. That's all it's saying.
How do you know?
If there's no like slight bend at C, where it's like a bendy straw, right? It's saying, nope, we go straight on through. B and E are the same angle, they tell you. That's all they give you. They say prove the two triangles similar. What do you see? What do you see? We know nothing about the sides, so spoilers, we're not going to use side, 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 or side angle side.
The vertical angles.
Oh yeah.
Oh yeah.
Oh yeah.
Oh yeah.
Oh yeah. My vertical angle theorem. Angle, we have multiple angle C's, so BCA is what I'm going to call it. You can call it ACB if you want. Those two angles are congruent. BCA and ECD. Why not? C just has to be in the middle because it's the vertex, right? And now, what?
What was the question?
Now what?
We have two angles.
I mean, angle.
My angle similarity. We'll use sim for short. You can write sim, Taylor. You don't have to write. Okay, so it's important.
By alcohol.
You don't have to write. You don't have to write similarity. You can just write sim with a dot,
I like Sim.
and I will know
What if
that
It's not
you mean.
funny
What if I
anymore.
don't put the dot?
What if I just write?
I will know, even without the dot, that you mean similarity. But I do need that sim there.
I'm not smart enough to write.
So this no, wrong. This nope, still wrong. Nope, still wrong. That's good enough. You can stop right there. Okay, open
Wait.
achiever.
You have to have AA sim.
Yep. Can't be just AA because that would imply congruency, right? Remember we do like SAS and see
yeah.
with that, right? Right. Some of these do cross over, and so we have to write similarity after them.
Sim is the same as similarity, alright.
Yep, that's right. So instead of writing, so
That's all we've done now?
so instead of writing similarity, what you can do, if you like want to say ink or and time,
This joke is going too far.
You can write sim.
You have to have a dot, you said?
No, so Bailey, this, no good. Still no good. Still no good. Oh yeah.
You're welcome.
Oh, overachiever. Overachiever. Oh, that's good. That's fine. But if you want to do the dot, okay, so
You literally.
I think so you don't have
So you need the
you don't no, you don't have to do the dot.
You just said sim with a dot.
It's optional. If you do the dot, that's fine, but if you don't, that I'll still allow it.
What if you write the whole word out?
That's okay.
You have to spell it right though.
That's yeah, if you spell it wrong, I would no.
Can you write similar?
No.
Darn.
Absolutely no. I will take the entire quiz and just throw it in the recycling.
5 minutes till she asked me how to spell orange.
Triangle ABC.
2M.
And I hadn't watched Mean Girls yet. But
What's the symbol for similar?
This.
sim.
Good.
A
So
tilde.
if you want, you could write AA with a little tilde.
It's called a
Tilde.
tilde. I was close.
Would you?
No. You have to pronounce it correctly. You can't. You have.
I called it.
So Taylor,
Tilde.
you can't.
Can I- So we have to have a dot.
Wait,
You
it's
have-
called Matilda?
A
You
tilde.
can-
Tilde.
You can. So
You're getting
so you can also do this. That's fine because that's the symbol
Sweet.
for similarity, and that's what sim stands for, as an abbreviation.
Can I write AA and then write tilde?
So you can do this. So you can also write sim here, with or without the dot, or you could write similar.
Or
Like these two
tilde.
triangles are similar. You
You
could
said
write
you
that
couldn't
in
write similar.
Word.
Okay,
You're
you're
stuttering
stuttering,
away.
and when my brother gets frustrated, he stutters.
So-
like you're getting frustrated.
I stutter
Just
all
like
the
breathe.
time.
So we know by angle addition postulate that this angle right here is going to be equal to 180 minus purple minus red, right?
Correct.
And this angle is going to be 180 minus purple minus red. So these angles are congruent, right? So we know A and B go together. We know B and E go together. And we know C goes with itself. In this case, it does. It won't always, but it does for this problem.
Are you okay?
Yeah, are you
Now
good?
that I hated so much.
I feel like you're getting freaked
That was
out.
so
We did it.
long. That was so long.
You're getting
And
freaked
that's
out.
it. That's it.
Maybe done now.
I've
Nope.
always called it a
That's
tilde.
fake.
I literally said that right in front
Okay,
of
that is
Landis,
incorrect
too.
and offensive to geometry.
Okay, but I said that in front of Landis, because that's what you use in Spanish.
Well, Miss Landis is being nice, and I know
Tilde?
this.
Yeah, the little tilde over the word.
Okay, so if you notice, these are all the same. These both have the same measure. Is what that M means.
I'm so
M stands for
tired.
measure. The little m is an abbreviation for measure. So the measure of angle C and the measure of angle DEA are the same measure, and that measure is 90 degrees. So DEA is this angle right here, and then angle C is this angle here. So I know. Unexpected right angle. Unexpected right angle. They were just walking around and just boom, unexpected right angle.
Okay.
All right. So we're gonna prove that AD times BC equals AB times DE. Yeah. So where did that come from? Oh my God. All right. First, we're gonna prove the triangles are similar. Let's do that. So, how are these two triangles similar? We have two. We have two triangles in this diagram. Two. That's it. There's no more than two.
It's cold in here.
That's not relevant to our discussion. How's it going?
Shared angles.
Shared angle, buddy. Check it out. By shared angle,
Sure, if you can get it, you should say. Oh, are you going back?
angle A is congruent to angle A. It's always angle A, isn't it? It's always angle A. Right, the big triangle shares this angle with the smaller. So, these we have two angles now. Right?
Are you okay? Wait, why did we write
Ask me if I'm okay.
Those two angles are congruent.
Oh.
Okay? Now, notice, now I'm saying by angle similarity, that's what the tilde stands for, right? Similar. You can also do SIM with or without the dot, or write similarity. That's fine. We know that the two triangles are similar, so let's write that. It looks like ABC is what I'm going to write first. That's the big triangle, and I'm going to write that it is similar It's a triangle. Again, don't write congruent because they're not
My
congruent.
eyes burn.
Yeah. So that can happen sometimes in similarity. So A, B, C. A matches up with A. B's this angle, right? It must be congruent to D, right?
Wait a bit.
And then C is congruent to E.
Oh, okay.
So we know that. Great, wonderful. So what this means is by not CCP, but by CSP, corresponding similar parts, we know that AB over AD equals BC over DE equals AC over AE. Right? All the parts are proportional. Which ones? The ones that go together. AB and AD are corresponding, right? BC and DE are corresponding, and then AC is first and third, AE is first and third. Now we want to prove that AD and BC multiplied together equals AB and DE. So the ones we were concerned with are AD and BC. And if you look for that, AD and BC are these ones. So I'm only concerned with this. And for your homework, I want you to get from here to prove that that is true.
That was.
You can do it!
Wait, to prove what is true?
That.
You say so.
I did it again.
All right, bye.
Are you not have like a panic attack?
Mr. Mac, don't
Like, you die. Seriously, you're struggling.
You had too much coffee. Too much Mountain Dew.
I had enough Mountain Dew.
No, like.
Enjoy the rest.
Are you good?
Enjoy the
Are
rest
you
of your
okay?